Welcome to the May Innovation Connect, hosted by the Department of the Air Force Chief Data and AI Office. My name is David Sanchez. I am the Technical Director of Strategy, Policy, Governance, and Data Services at the CDAO, and will be today's moderator. Innovation Connect Innovation Connect aims to create a collaborative atmosphere for those working in the DoD, to cross-pollinate ideas across organizations, enhance innovation, and identify and solve problems related to R&D and scaling. We're excited about today's event, and we thank you all for attending. To get started, I'd like to share a few housekeeping rules. If you are not a presenter, please keep your camera off and the microphone on mute. Second, we ask that you keep questions to the topics presented and refrain from media-related questions or advertisement of your company or organization. Please submit your questions in the chat. Today, our speaker is Mr. Roberto Guerrero, the Deputy Assistant Secretary of the Air Force for Operational Energy. He will provide an overview of SAF-IE, followed by a Q&A session. Mr. Guerrero, as I mentioned, is the Deputy Assistant Secretary for the Air Force for Operational Energy, where he directs the Department of the Air Force's operational energy programs, plans, and policies to enhance combat capability and mitigate operational risk to the warfighter through energy-informed solutions, advanced technologies, and improved processes. Mr. Guerrero has an aeronautical engineering degree from California Polytechnic State University and was commissioned as a naval aviator in the United States Navy. Mr. Guerrero did an inter-service transfer to the Air Force and served as an E-3 AWACS pilot, where he was a command pilot with over 4,000 hours and 24 combat missions. Upon his transfer to the civil service, Mr. Guerrero also served as the Deputy Chief of Safety for the Air Force Safety Center and as the Director of Staff at Air Force Reserve Command Headquarters. Mr. Guerrero, we are excited to have you with us today, and sir, the floor is yours.
All right, well, thanks, David. Appreciate the introduction. Appreciate everything the office has done to allow me to participate in this. Yeah, so just to give you a little bit of background, naval aviator first and then Air Force aviator. And I've been doing this particular job for the last 8 years, which is kind of a long time to be in one position. A lot of it has to do with I really enjoy what I'm doing right now. It really hits a lot of the areas that I have an interest in personally, that I've had an interest in for a long time. There's a little bit of a connection between the safety work I did in the past, which is reducing mishaps, and the work we're doing now, which is really enhancing combat capability by reducing inefficiency. You know, a lot of it is a mixture of process innovation as well as technological innovation, but it all goes to what you'll see in our mission, which is about maximizing combat capability for the warfighter. So, do I need to drive the slides? Because I'm not seeing the slides right now, but I can bring them up. Oh, awesome. Okay. Perfect. Next slide, please. So for us, so this is an unclassified slide. The Economist published this a few years ago. We use it just to kind of set the stage for one of the theaters, one of the competitors we have, and to understand the distances. So, you know, in my the introduction, it talked about how I served as a pilot in the AWACS theater. I was actually, in the Pacific Theater, I was actually the commander of the AWACS squadron in Okinawa, Japan. So right in the heart of all this, done plenty of flights from Okinawa to Guam and to Japan and Korea and Thailand, and then all the way back to Hawaii. It's a lot of water, and there's not a lot of places for us to land. There's not a lot of places for us to store fuel. And so this is going to be a significant challenge. So my mission and the mission of my office is, how do we reduce the risk of what we see in fuel logistics supply chain in the Pacific, in some ways by, you know, more efficient processes, in some ways by collecting data and having that data inform us in those areas that we could do better in, as well as the effectiveness of technologies that we're bringing forward. And then also to have an understanding of power plants and avionics and aerodynamics and those kind of things technology-wise that could be part of our aircraft that maybe aren't now, that will result in us being able to stay on station longer, to be able to deliver more fuel to receivers, to be able to fly farther, because this challenge is a um, lot bigger than we saw in, Al Udeid, or, I flew out of Oman for the majority of my time over Iraq and Afghanistan. And so there was a big, big piece there, but it's not nearly as big. The criticality, at least from an aviation fuel perspective, isn't nearly as big as we see it here in the Pacific and in the challenges that we're going to have with adversaries out there. Okay, next slide, please. And for those of you who don't know, we've been tracking this data for multiple years now. We're getting much better at understanding our consumption. From a big picture perspective, the Air Force burns more fuel than all the other services combined. So all the Army tanks and Marine Corps helicopters and Navy ships, add all of that up together, that number is still going to be less than what the Air Force burns every year. And it's a pretty big number. So slight improvements in this number actually make big big amounts of funds that could be used elsewhere to make us more combat capable. And you could see that, when I started this job around 2014, 15 timeframe, the interest in this really waned quite a bit because the price really waned quite a bit. And the price has gone up significantly now, on the order of about 50% more than we were paying, 50 to 75% more than we were paying for in the mid to late teens. And so as it eats up more and more of our budget, it becomes more and more of a concern because it takes away from other things we to fund. Next slide, please. So this is the first, area that we really took a deep dive look at, which was in the B-52 community, because Global Strike Command was just standing up. This is around 2015, 2016 timeframe. They were, or they'd stood up for long enough, at least, that we knew that we had to have a discussion with them on how they track fuel usage and compare that to, Air Mobility Command, Air Combat Command. And and then what we did was, it's a fairly small number between years. 3 to 4% of the overall Air Force fuel consumption was B-52s. We wanted to understand how they collected fuel data, because a lot of that's manual. And then what analysis was done in understanding the impact of, various different weights on, well, we know what it is fuel burn wise, pretty much, for every 100 pounds you carry extra fuel that you're not using, you burn about 3 pounds of it per hour. So it ends up adding to quite a bit. But, part of it was trying to understand what else would appeal to others, because most wing commanders don't pay for their fuel bill. And so we want to understand, is there anything else there that is of concern to a wing commander that could result in them changing behavior? So the first thing we found out was the forms that look at fuel collection at most aircraft, at least at that time in the Global Strike Command community, was a 781H form, which is part of the aircraft forms that all the pilots look through, the crews look through before they go flying, to find out what issues there might have been with the plane, what corrections were made to, or repairs were made to certain parts and whatnot. And but that data was only kept for 60 days, and it was all paper, right? Here's what my landing fuel was, here's what my takeoff fuel was. And it was primarily used just to understand, hey, how much fuel do I have to take out in fuel trucks to go refuel that B-52 for the next day's sortie? Because they had a standard ramp load. They would, have, it was like 120,000 pounds, 140,000 pounds of standard ramp load. And we do that because it makes it easier for us. If one aircraft is broke, I can walk to another aircraft. It has enough fuel for me. I can take off, no complications there. However, in many cases, that was way too much fuel. They didn't need that much fuel. And we spent some time from there understanding why they were collecting weight data on aircraft. And it turned out that they were actually collecting a lot of their weight data not through this 781H form, which was used for maintenance, but it was actually for the Aircraft Structural Integrity Program Office at the depot. The depot and the program office wanted to understand how heavy these aircraft were when they took off, how many bombs they were carrying when they dropped the bombs, how heavy they were when they landed, because they're old airframes, and the ones that were, in essence, ridden the hardest would be the ones that would be probably the first ones to bring into the depot, all else being equal, to look for wing skin cracks and other types of things that happen when you work an airframe extra hard. So that was valuable data to us. It was already all collected. It was like paper copies that were put into a system that was over 10 years worth of maintenance or landing weight data, takeoff weight data, and landing weight data, as well as in-flight mission data. And we were able to link those side numbers of those aircraft to other maintenance actions that were being performed on those aircraft. And the reason we wanted to understand that was we knew, here's how much extra fuel you burn, and fuel is going to be a precious commodity in certain theaters. We want to know how much extra fuel you burn, but we also want to know what are the second and third order effects of carrying extra fuel that you're not going to use. If you're coming back to the airfield extra heavy, there's a chance that you have to lower the flaps or gear. I've done it before as a pilot. We'd be too heavy for touch and goes, so we'd have to lower the flaps and gear to get down to touch and go weight. And that was happening a lot in this community at that time. And then, so what the second and third order effects are not only, let's say, running up your engines more because you're trying to burn off fuel, but it was also, let's take a deep dive into one specific area. And that's where these numbers come from. We said, we're going to look at brake changes, tire changes, and other airframe issues that were related to the gear, like struts. What type of maintenance actions are we doing in those three areas? And how does that, how does that affect our ability to keep combat mission ready aircraft on the flight line? And here's the numbers, so for overall, the impacts were that you were spending about 350 maintenance man hours extra to deal with those problems that wouldn't have happened if there was a little bit more control over how much fuel we were taking off and landing with. There's also a parts piece to that. It was about, for a relatively small piece of the Air Force, a lot of money in extra parts, and obviously this data. So we have a data scientist on our staff who's got his PhD from Duke University in energy economics. So, the numbers that he got after were looking at helping us understand the extra maintenance cost in parts, the extra maintenance cost in man hours. We have a pretty good estimate of what the extra cost was in fuel. And then ultimately for the warfighter, you want to know, hey, what does this mean? How does this affect me when I need to go do training and I have a limited number of mission capable aircraft on the flight line? So that was our first real foray into, hey, this data we think is going to be a lot more interesting to us for a variety of different reasons, past the point of just understanding the fuel challenges. Next slide, please. So around that time as well, and if there are aviators out here, they'll know what I'm talking about. But, between 2010 to 2012, there was a lot of emphasis in certain areas on reducing demand because we know that we will have certain scenarios, certain theaters that we're going to be limited in the amount of fuel we have. But our message at that time with this office was more along the lines of reduce demand, in which a pilot thinks of as, you want me to fly less. And so that it wasn't really helping understand what the big picture of our office is, which is this: enhancing combat capability. And what we hope to get to is, by better collection of data, by better analysis of the way we execute the mission, by understanding through wargaming and modeling and sim tools, what the challenges are going to be in the Pacific with respect to how much fuel is at certain locations. And, the adversary is going to target our fuel. So that's going to make it really challenging for us to get the missions done that we think we need to get done to support certain operational plans. So, in the future, we hope to be able to provide tools to our folks that will help them create an energy optimized Air Force that maximizes combat capability. So that's mission and vision. Goals, I'll break each one of these down in the next few slides, but it really just big picture wise, we're talking about these 5 goals that are helping us support that mission and vision. Next slide. So for fuel more fight, there's a couple ways to look at this in wartime in a pure competition by us increasing the efficiency of our aircraft by, let's say, better engine wash methods, by more aerodynamic aircraft. What we're doing is we're allowing them to stay on station longer, to deliver more fuel than they could in the past, for at the same range, to go farther. All those things are increasing lethality per gallon for us. In peacetime, we can get more training done. We can get training done for a lower cost or more training for the same cost. So those are the types of things that we think about in this one goal. So energy intensity for us is, that lethality per gallon. And the better we do with the energy intensity, the more lethality per gallon we get. And it's going to be really important in the Pacific. And we have to be thinking that way. We have to be thinking that way in the way we execute the mission, the way we procure new items, as well as, because it's a precious commodity, how are the, let's say, R11 trucks that we have at Guam or going to have at Tinian or Saipan, how is that ecosystem working? Because we have a lot of equipment that's aging. We have some equipment that's really not going to be compatible with the new construct for fighting on, small islands in the Pacific. And we have to understand all of that to be able to identify weak areas that we need to robust. Okay, next slide. So as part of this, there was a cultural piece to it. Now, I talked a little bit about the B-52 community and understanding how the B-52 community was executing their mission. And, a lot of times in many things that we do in the Air Force, funding can result in things not happening. It can also encourage things to happen, and that's what we had in this particular case. We oftentimes will have, like at Barksdale, one of the issues they had is they had no suitable equipment nearby to conduct certain types of training, certain types of emitter training, right? The B-52 has sensors. It needs to know where the bad guys are, where the surface to air missiles are. And the emitters that they were using for training were in Kansas and West Texas and New Mexico. And we were able to actually pull FAA data that showed the radar tracks, a big map that shows, these aircraft leaving Barksdale and going to all these various different locations. But they also had a range in their backyard, about 45 minutes away flight time from Barksdale, that could have been used for some of that training, but it didn't have the right equipment. And that right equipment was a mini-mute, which was a type of emitter that they could use to get some of their training accomplished. But they didn't locally have the money to pay for that emitter. And getting that emitter resulted in them getting a lot more training per gallon than having to drive deadhead, a long way out to New Mexico or Kansas or West Texas. So it's those type of things that sometimes, us providing them $1 million for them to get a mini mute to them put it that at Claiborne range resulted in a improvement in lethality per gallon, because now they're getting that much more training with that many fewer flight hours, or the same amount of flight hours and even more training than they could have gotten in the past. What we did here with MEEP is we said, how do we currently execute the mission? How do we currently track fuel usage? And, really what turned out is that over the past couple decades, wing commanders are given a flying hour program, but there is nobody tracking how much fuel they use in each one of their sorties. And so, if folks aren't watching that number, then that number could potentially be a lot more than it should be. And that's what we saw in this case. We saw ramp weights at locations. And when we would go back and look at the landing weights, we'd realize that, hey, they really are taking off with, maybe 20,000 pounds more than they really needed. But we also wanted to make sure that if we were to encourage a behavioral change, that we were also not affecting training. So this program was initially stood up with 2 bases. Charleston C-17 unit and a C-17 unit out at Travis. And we said, we just want you to look at this, right? We want you to measure it. And if you agree with us that you're carrying than you should be, then make an adjustment and we are going to provide you with some kind of incentive. So what happened was is that we saw both of these squadrons, or both the wings actually. It was like 3 C-17 squadrons at Charleston and 1 at Travis. They all reduced their standard landing weight by about 12,000 pounds, which when you add it up together was about 1 million gallons of saved over a year's time frame, which is about $4 million. And we are using some of the funds that we get in the budget for this program. Think of it kind of like a installation excellence awards program, but instead of well-maintained buildings and lower power being used for those buildings, or the pretty cut lawns and good services and all the things that are comprised in the installation excellence award program, in this case we're incentivizing logisticians to load aircraft better, maintenance folks to think out better maintenance practices, operators to operate their aircraft better. And this program is actually providing a rebate on some of the savings that we get back to that wing commander who's driving the program, so that he can, maybe buy more tools that he can't afford right now that would result in better operations, but also it's quality of life stuff, because we know that a little bit of encouragement on this side has ended up resulting in a lot of reduced cost for the same mission. So we're tracking, like as part of this program, we're tracking how they're doing from a reduction in standard ramp weight, but we're also tracking how they're doing in training. And that training piece can't go down. But we think that there's some room to move on reducing those ramp weights and still operating perfectly safely, because they'll have plenty more fuel than their divert requirements require. It takes a little bit more effort to maybe lower fuel and kind of deal with the fact that not every aircraft in the flight line is fueled to the exact same amount. But boy, from a fuel savings, there's something to be said there. From a mission capability savings, we think about a 1% increase in mission capability rates on the aircraft, because they're not braking as often, because they're not landing as heavy, so they're not braking. The tires aren't wearing out, the brakes aren't wearing out, and whatnot. So this has been a pretty attractive program to us, and our next step is to slowly expand it Air Force wide. So I was just at the Dover what they call Bedrock, the Dover Innovation Center, and toured throughout Dover just to encourage them as they start to become part of MEEP. And I think they've already got credit for about $250,000 worth of rebates because of their efficient behavior this past year. Next slide. Other things that we're doing on the energy intensity slide is that there is just some simple things that we can do based off of aerodynamics, things that they weren't really using when I was an aerodynamics student at California Poly. Now we have, virtual wind tunnels where we can do, pretty sophisticated computational fluid dynamics. So we'll get like 3D scans of these aircraft. We'll stick them in these CFD simulators, and then we'll use those CFD simulators to look at placing certain things. Sometimes it's as easy as a vertical windshield wiper instead of a horizontal windshield wiper. Sometimes it's a little bit more of a, let's say this, like in the C-17, it has, and the C-130, they have a pretty good aft sweep of the tail. And so much like if you go to every airport in the world, almost every aircraft will have winglets. Those reduced vortices on the wingtips of the aircraft. These little fins that we're talking about reduce vortices coming off the tail of the aircraft. Either way, a reduction in vortice it results in a reduction of drag, which means you're creating an aircraft that's more fuel efficient. So we've done testing for a lot of these, and we're scheduled to implement several of these initiatives over the next year. And what we found, another neat part from a data perspective that we found, is that some of the airlines that we're partnering with, for example, the vertical windshield wipers, we're partnering with Delta and Southwest also did some work on these aft body drag reduction, or these microvanes, on some of the 737s that they own. And what they found is that there is a pretty pronounced difference in certain aircraft when they get these modifications that were not because that initiative doesn't work. They were actually because the aircraft were slightly out of rig. Like I think Southwest did it on 10 different aircraft. 7 of the 10 got the 1% that they were expecting. But that last 3 of those 10 that weren't working the way they thought, it was actually because the aircraft was slightly out of rig. And once they fixed the rigging, they were able to get that 1% like all the others. So we think just doing some big data analysis on rigging of all our big aircraft might result in us getting some efficiencies as well. Next slide, please. Okay, for engine sustainment, another thing that we've learned in partnering with other operators and um, other services as well is there are certain things that we have done in the past just because we've always done them that way, and now we're realizing that there are new techniques that are being pioneered by industry that we bring in and we can take advantage of ourselves. The CV-22s that we fly out of Kirtland, and AFSOC has them in Florida as well. What we found is that their legacy way of walking engines was a cart that would squirt detergent into the hot section of the engine. So if you open up an engine, you have like the compressor blades up in front, then you actually have the hot section where the fuel mixes with the compressed air to create combustion, and that's all they were washing with this detergent. And sometimes just looking at a legacy system, you can see some problems. There were some problems with the legacy system. So the legacy system was introducing contaminated water, and they found like 60% of the time when we looked at the data, 60% of the time when you'd wash an engine, it would perform worse than it did before you washed it. So something was wrong there, but there was nobody that was tracking that data all the way through the life cycle of the engine to really pinpoint why that was happening. When we were able to bring this company in to do a different type of wash, they would do a similar type of wash that they did to like natural gas power plants that we mostly see in like the electrical industry for the grid. What they saw was that their method was not only better from a purity of the aircraft, the water that was used on the aircraft, but instead of those little nozzles that went into the hot section in the side of the burner can, that you could keep from doing any of that maintenance, pulling off panel, pulling off those plugs, and hooking up those little hoses, and just squirt foamed like compressed air with detergent water that turned into this expanding foam through the intake, and that would cover the whole engine. So there was an increase in efficiency in the compressor section, which wasn't being washed properly beforehand, as well as an increase in efficiency into the hot section that wasn't being washed as well as it could have been. So you can think of there's a variety of different way to wash aircraft engines. These are things that we're thinking of with respect to making our engines run better, make them cleaner. There's actually 3D scannings of the engine now that we can do to make sure that the blades are keeping their shape. There are coatings that we can provide that we haven't used in the past. All those things will help make the engine run better. And then from a maintenance perspective, that was the really selling point here. That's what we were trying to do with the B-52 community. And it really happened here with the CV-22 community, is that the maintenance savings that they had of not having to pull the cowlings off, not having to attach those little hoses to the side of the compressor or the turbine section, the hot section of the engine, resulted in a dramatic decrease in maintenance man hours. And they're like, yep, we want to do that instead. And there's some other things we could talk about with respect to, how we repair aircraft, like this duct replacement, because when you repair a section of the aircraft with epoxy and rivets in a section that gets a lot of wind through it, like the engine fan duct, you're going to create a drag section that you didn't have beforehand. And we found just replacing that whole panel actually was much cheaper and better to do. Okay, next slide. This is another area that we've spent a lot of time on. You'll see that the jet there, this whole thing about looking at the way we plan via software was really initiated by Eric Schmidt from Google. So those of you who remember, like the founding fathers of Google, Eric Schmidt was part of the Defense Innovation Board. He visited Al Udeid, where they had these guys that were showing them what is behind that electronic whiteboard, which was the standard whiteboard, right? The traditional whiteboard that all airmen and guardians use in various different processes in the past, right? And in this case, it was a very challenging schedule. It was 50 aerial tankers per day, air refueling, 250 receivers. That was the average at that time. It's a little less now. And that solution was being generated with dry erase markers, magnets on a whiteboard. So really kind of a glorified 19th century solution, to be honest with you, because it wasn't that much better than a chalkboard. And that process was taking 8 to 12 hours. It wasn't very efficient. The person who was working it had just enough time to get that done before his shift was over. And Eric Schmidt was like, you got to be kidding me. This is a 21st century Air Force, and I'm seeing a glorified 19th century solution. So we spent some time, and when I say we, I'm really talking about DIUX and then Kessel Run. The Air Force spent some time in making an electronic whiteboard, which is what you see there, which is much better, right? But when our office heard about this, much better in that 2 to 4 hours of planning time instead of 8 to 12. The adoption happened really quickly. For those of you who know software, there's like agile software development, which you're constantly iterating. There's a waterfall method where you develop a project and then deliver a project and maybe get incremental like 6-month changes. The ability to adopt this new technique was really critical to using the agile method. When you have folks who are doing a process and then you give them a very similar process on a computer and you iterate at the same time on getting your process to match their process, they're much more likely to say, yep, I like that. I'm going to move over to what you're doing than they would if, you show up with hey, we've got this new My OPR program and we're going to give it to you. And no matter how much testing you do, sometimes it doesn't work as well that way. So in this case, the agreement was, hey, we'll give you 9 months to do this. And then after 9 months, we're probably going to go back to the way we're doing it on the whiteboard because we don't really think your process is going to do much better, but we'll give it a try. And at the 4-month point, the gals and guys who were doing it on the electronic whiteboard were at 4 hours walking to go grab lunch or go work out or do something with the majority of the schedule done because their process was so much more efficient as compared to the dudes and gals doing it on the whiteboard. At the 4-month point, they said, yep, you're right. We're switching over to your program right away. So it was a quick adaptation, adopting a new process because it was similar enough to the old process and it was much less onerous, right? And then when we saw it, we're like, we like that. But to me, that's a lot like a paper map to like, let's say the GPS that I have in my 2011 Highlander, which is not that great, to Google Maps or Waze. So we're getting them to the Google Maps or Waze. The new addition to it, we call it Pythagoras, is just an algorithm that does a bunch of the calculations in the background and allows them to still make modifications if they need to, but then we'll recalculate, which is going to happen. In wartime, even in peacetime, I used to schedule pretty complex schedules as a flight instructor in the Navy. We'd have like 70 different, sorties per day, and things were constantly changing. Students get sick, aircraft break, weather rolls in. All those things are why this type of algorithm in Pythagoras is why we need that, because the next war is not going to be a static war. It's going to be a very dynamic war. And when you go from the way Jigsaw is right now to Jigsaw with Pythagoras, which gives you a solution in like 15 seconds to maybe 15 minutes at the most, that's the level of decision speed that we're going to need to be able to execute our mission using JADC2 and these other ways where we'll be much more connected than we have in the past. So, and what we saw is they give you a much better solution. So there's a quickness to it, but the solution, especially when fuel is critical and you have a limited amount of fuel, when the solution gives you 10% efficiency over that electronic whiteboard, you know that that's something that you really want to be considering. Next slide. We got some folks into the office and we said, hey, we started ramping up the amount of manpower in my office around 2017, 2018 timeframe. And this is one of the areas that we started in 2018. And then you'll see the slide that changed from 19 to 23, I think it is. But what we realized is that the data that we were using, which was Air Force total cost of ownership data, called AFTOC, the data that we were using was very manual and was really for a different customer. AFTOC data is really for FM folks to help them understand how to program out what the cost per flying hour is for the budget for next year, right? And so when we dug into the data, we saw things that didn't make sense to us, like how is a T-38, which is a training aircraft, flying 5 hours on a combat mission with no fuel being used. It was that type of level of corruption of the data in certain cases that made it tough for me to go, what's the difference between a combat mission and a combat mission as compared to a training mission, because I wanted to be able to separate those two, and I couldn't do that with AvTalk. So we said we're going to start from scratch. We're going to do a test to understand what data is available. And thanks, that under a minute. So that's not even 15 minutes. It's 15 seconds to a minute for Pythagoras. So what we wanted to understand is how much data we're actually collecting, which assets are the best with data collection, like B-52s. There's no flight data recorders as far as I understand B-52s. So there's certain aircraft where we're really just getting very, very little data. F-16, all the F-16s except for the Block 50-52s, we're collecting 15 to 30 minutes of flight data because of the fact that the flight data recorder was built in the 80s, and that's all it could do back then, and it's real expensive to replace them. So we want to understand that big picture, and this is what we initially saw. Lots of data in certain platforms, C-17s, 135s, not actually positioned somewhere into a data lake where some analysis could be done, kind of like sectioned off, and in other aircraft, no data at all. Next slide, please. So this is where we've seen improvement, and the mobility aircraft really take up the majority of the fuel use in the Air Force. So we wanted to make sure that we segregated, mobility aircraft, global strike command aircraft, air combat command aircraft. And then, as you can see here, we also wanted to understand when you take big aircraft and small aircraft and, parse them out, then help me understand which ones are the biggest burners, because those are the ones I want to get the best data in first. C-17s, KC-135s hit the top of the list. And so we spent a lot of time looking at that as well. Next slide. So this is the other challenge, is that when we're working with this big data issue, is that we're trying to make sure that we're matching up various different data sources. So, like in the past, I would say in the 2010 to 2012 timeframe, a lot of folks in AMC, a lot of air crew were spending a lot of time writing down a piece of paper, data that we told them that they had to collect, takeoff data, landing data. They call it the fuel tracker. A lot of folks hated it. And the fuel tracker was a manual piece of sheet of data that would go to someone and make it into some system, and nobody ever saw the results of that. And so there was a frustration level from that. Why am I doing this extra work to collect data that nobody's going to act on? Since then, we have systems now like Puckboard, which is one of the data sources that we use for scheduling crew. That also has Puckboard logging, which is on the iPad that the crews use. So as they're entering in all the various training data that they're doing, they also are entering in their fuel data. And eventually, we want to take that away. Eventually, we think we can get it all off of the in-flight data recorders. And then that data gets pushed to systems of record currently now that in the past we had trouble making sure that that data was actually getting there, and then filtering it and making sure it was good. So, connecting across more databases, we're able to find out cost and aircraft availability metrics that we couldn't do in the past. Next slide. I'm going to break it out into a couple different layers: strategic layer, tactical layer, operational layer. So from a strategic layer perspective, we want to understand when we have an idea of, let's say, an aft body drag reduction, like those microvanes, What's the real impact of that on big Air Force wise, and what's the impact of that in our modeling and simulation? So we've spent a lot of time. We have a variety of different ideas now of ways that we can get after cost, ways that we can increase, like let's say aerodynamics or increase performance of our turbine engines. Those are all paired against what the impact would be from a cost perspective, as well as understanding what the impact would be from a warfighting perspective in modeling and sim in a war game. Because it really doesn't help me to have you know uh, a Ferrari on a freeway that drives 55 miles per hour. We want to make sure that we're spending the right amount of money to get the maximum effect possible for that money. And there are some things that are just so prohibitively expensive right now for us to do that it makes more sense for us to nip at the edges, right? Like so for the KC-135, engine washes will give us maybe 1 to 2%. The vertical windshield wiper will give us about 1%. The There's an HF antenna mod we think will get us 1%. The half body drag reduction will get us 1%. So we're getting close to 4 to 5% there. Those are much cheaper solutions than putting winglets on the KC-135, something that we also think is a good idea, but we're going to start with those smaller things and measure the impact. And then from a big picture perspective, when we're talking about what the next aerial tanker will look like, what the next airlifter will look like, we have to understand what the impact is going to be on fuel of those different platforms in places like the Pacific. And so if I told you that, before 2018, we really didn't measure fuel use in war games accurately. I mean, we would measure it and then we would run out and then we'd sprinkle fairy dust and we'd continue to play the war game. And we wouldn't learn about those things that we would have to buy to solve that fuel logistics problem that we all knew was going on. As we continue to do this, we continue to understand that fuel, the more and more realistic that we get with fuel logistics modeling and sim, we're seeing more and more areas that we have to address that we haven't addressed in the past. Next slide, please. So from a tactical layer, these are some of the ways we will actually specifically get down to understanding which, because there's some advantage to us for collecting data for raising revenue, and I'll explain that later on. We really want to understand how well these retrofits are doing, right? So those vertical windshield wipers, I mean, the computational fluid dynamics tells me about 1.2%. Is that actually what I'm going to get? How quickly am I going to pay off the investment? In a lot of cases, those things are, especially for those aircraft we fly a lot, they pay off really quickly, but we want to understand that. From a tracking maintenance perspective, what's the impact of having engines that are running at cooler temperatures because they're washed better and because basically we're not flying with as heavy as loads? And what does that mean in the reduction of the number of engine changes we have to make, which results in the increase in the FMC rates of our aircraft because now not as many of them are on the flight line getting engine changes. Those type of things are really important to us. And we're getting to the point now where we're having really good data streams in these areas. So we'll be able to help our maintainers understand it better and our operators understand it better, and hopefully, just green up more aircraft and get more training done per flight hour. Next slide. And then finally, from this operational layer, like I mentioned slightly, when we talk about things like that planning tool, Jigsaw, there are a variety of other planning tools that we could use to make sure we optimize what we're doing, because being able to optimize what we're doing will result in us being able to deliver more cargo downstream, deliver more area refueling assets, and more gas to assets that need that gas in order to get their mission done. Optimizing plans really can mean the same mission with less aircraft done, so same number of weapons against an adversary, or it could mean the opposite, which is that you can get that much more combat air power out of that weapon system now that it's more efficient and more effective. Next slide, please. Hopefully that gives you kind of a big picture of the things that we're thinking about. So on my staff, we have logisticians, we have aircraft maintainers. You wouldn't think that because we're installations, environment, and energy, right? And we're the operational part of the energy. but we have a variety of different folks, aircraft acquisition professionals. We have a few of us who are pilots, some of us who are also aerodynamicists. So we have several different specialties here. And what we're doing is we're looking at this one piece that everybody in the past has considered is free, right? Which is fuel is free. If the wing commander doesn't have to pay the fuel bill, and if that fuel bill is paid by the FM up here in the building, it's like, if I hand my kids a credit card for their car and say, don't worry about how much fuel you spend, then you're probably not going to get, you're probably going to get a little surprised when you get that fuel bill at the end. This is the same kind of thing that we think through. And in this case, what we've done this MEP idea, which we're trying to incentivize by saying, look, I'll give you a rebate if you're more efficient. I'll give you an award if you're more efficient. And that rebate and award could be used for whatever you want to use it for. The other piece is that Congress, we talked to the Senate Armed Services and House Armed Services a couple of years ago. We got them to change the law. And what this allows us to do something that I didn't think you could do. 30 September, money expires, right? We all know it because we've all been through that drill where it's the end of the fiscal year and we got to, how many pencils do we have? We got to buy some more pencils or some more paper or, toner or whatever. We would spend a lot of our O&M money because we knew that O&M money cancels on 30 September. Well, it actually doesn't technically cancel. O&M money expires on 30 September. So like at the organizational level, you can't buy those things with that money on 1 October, but that money is still in a bank account and that bank account is tracked for the next 4 years. And that money is tracked for the next 4 years because there are bills that come from previous years that need to be paid. The airplane that refuels at a location that bills back the Air Force for that fuel bill, they're on 30 September, they're probably not going to get the bill till sometime in the next year or next fiscal year. Exchange rates change. There are contracts that don't execute. There are contracts that execute that are more expensive. So we end up having a fair amount of money at the end of the year of O&M, unexpended O&M, that is expired but not yet canceled. And it doesn't cancel to that 4th year. And then it truly goes back to the Treasury. Well, what Congress said is, look, if you have initiatives that you're doing that you're having trouble funding, what we will do is some of these other initiatives that we're working on, if you can demonstrate to us that that's actually saving fuel from the previous year, then that money from the previous year that was supposed to expire on September 30th can actually be pulled forward in the next year. And you have 1 year to spend it, but only spend it on initiatives that save fuel, that address this fuel logistics, demand reduction issue that you're trying to get after. And so for the past couple of years, since that authority was granted to us, we've been slowly identifying initiatives that we've implemented in the past and pulling that money forward and spending it on other stuff. So last year on the 13th of September, FM told me that they had 13.4 million extra that they were going to give us if we could execute it by 30 September. For those of you contractors in the room, you're probably, or contract specialists in the room, you're probably shocked at that, but we were able to execute it in 2 weeks because we'd had all the skids greased for getting that money. And we used it to fund AR, VR training for AMC, AFSOC, and ATC so that you spend less time with an aircraft on the flight line that's turning let's say an APU to do a pre-flight, because you can do it virtually with a headset and the right type of software. Well, those are the kind of things we think about. A lot of times it really comes back to that we've treated fuel like it's free. And because we've treated fuel like it's free, we haven't been as good as we need to be. And then now that we're looking at this new theater, it's a little tougher to get fuel at Guam than it was at Al Udeid, or PSAB, right? Because you're not right in the heart of where the fuel is being made. You're on an island somewhere in the Pacific where a ship has to come up to a pier. The pier has to offload the fuel into a pipeline and so on and so forth. So we think it's critical that everyone realizes that this precious resource is going to be an issue for us in the Pacific unless we're paying attention to it a lot closer than we are right now. And I think that's it. Next slide. No fuel, no fight. So that's my presentation. Happy to take your questions.
All right. Thank you very much, sir. We have 6 questions here that made it through the the people screening the questions. First question is from Mr. Mike Prado, and he asks, how is lethality defined? He says he noticed that there were some examples listed. Over.
Yeah, it really is. There's a variety of different ways you can define it, right? So when we think about lethality per gallon in, let's say, a KC-135, to us, that's being able to have a KC-135 that could either fly farther to deliver the same amount of fuel, meaning that that whatever asset it's refueling with can go that much farther to get their mission done, or have that much more fuel that's time on station wise. Um, so in that case, it's about fuel and it's about more fuel to the fight. It could be in the mobility world, it could be more ton miles per gallon. So, how much cargo can we deliver over a distance with the amount of fuel that we're using? Surprisingly enough, in some of our modeling and sim, we look specifically at that challenge. We're actually looking at something else. We wanted to understand how difficult it would be to carry out some of the operational plans that we have in the Pacific. Um, in the second island chain, with our assets flying out of the second island chain, KC-46s, KC-135s, and then outside the second island chain, because from there you go from, like, I don't know, Guam, Tinian, Saipan, Palau. You have to go all the way back to, like, Australia, like Tyndall and Darwin. You have to go to Alaska. I mean, if we're pushed back, we wanted to understand what the impact was to the current um, force that we have, air refuelers. How much less fuel would they be able to deliver for that fight? Because it was quite a bit less. Um, and then, are there any other options? From a modeling sim perspective, we know there are current designs, like one of them is called the blending wing body, that is much more efficient than a traditional airplane, because you got less tube and non-lift producing devices, and it's mainly all lifting wing, right, or lifting body. So we wanted to understand the differences between those two things, as well as what we wanted to understand is, you have a bunch of these islands in the Pacific that have certain fuel loads. We don't know how long those fuel loads are going to survive from adversary attack. We don't know when the next Navy ship's going to pull up to the pier to refuel them. And so we wanted to understand, from a strategic air perspective, how much fuel does the C-5 or C-17, when it lands at Guam, need from that island, that it's already hard to get fuel there before it has to go home. And it turns out it was a significant number. It was a significant percentage of the fuel on those islands was to get strat air back home. So in this case, building an airplane that doesn't need to refuel, that could just drop off its load and maybe drop off more than one of these airframes could, and then get out of Dodge without taking any fuel from the fuel tanks. That's another way to define lethality per gallon.
All right, thank you very much. The next question is from Captain Pershing. There are some IT programs that already feed data to the MEET program, but need sustainment funds to continue to be a viable tool. Is there a way to apply for funds to assist with this? Over.
Yes, I might have to phone a friend, though. Do we have Ryan, or, hey, Corey, do you know if any of the other folks on our team are on? So
Not at the moment, sir.
yeah, so we do have a couple methods of doing that. Every year we collect through our governance process. Like, I meet every month with PEO Digital, Bob Wirt. Yeah, it's Mr. Wirt, right? I meet with him every month to discuss this exact thing, is that those products that we've developed, those projects that we're working on, how are they tracking? How do I pay for them? But and are they systems of record yet or not? And is that going to be rolled into the Air Force panels to make sure that it's sustained correctly? So that there's that one process that we have established governance processes with PEO Digital, PEO Mobility, PEO Engines, to talk about their various systems and how we're funding them right now and how we could support them further. And the second part is that every year we are sending out to the directors and staff of all the MAGCOMs a call for topics of things that we could fund, either through unfundeds that we get in the Pentagon that we would want to push down. And this has happened, like, I've given some money to Dave Sanford at AMC, the AMC A4, for a project that he's working on through this governance process. But you'll see it again, because there's two ways for us to get money. Sometimes it's unfunded. Sometimes it's extra money that we have for other programs that doesn't execute. Sometimes it'll be with this operational energy savings account where we've identified a deficiency. We know that we're going to save some money, and then we get it around, we're hoping, May to June timeframe, closer than 13 September, and we will have a list of initiatives from each MAGCOM to select from, and we'll have the whole group vote on, and we've done this in the past, on which initiatives are the best ones to be funded.
All right, thank you, sir. Next question is from Mr. Roland Keller. It says, what tools are being used to consolidate data, track, and report, such as Vantage, Advana, or others? Over.
Yeah. So in a lot of our cases, we're going through Advana just because we thought that the path to execution was much quicker. So you might have seen in let's see, I think it was the strategic layer side. We're using Advana right now. We're actually tapping into the, as an Air Force Safety Center guy, I was the executive director there for a couple of years. We're actually tapping into some of the Air Force Safety Center data that they automatically collect on flight data recorders that, help us build out other data sets in Advana. And we're getting to the point now where we can tell you this side number, C-17, taxied in on 2 engines, because our plan, our hope is that, right now there's current training that's being logged, and I can't really fix that piece, but I don't think the aircrew should be logging anything else. We should be able to have our system set up so that when they land, that data is automatically pulled from the flight data recorders, and they know if a technique was used, like a idle descent path for a C-17 back into Travis, or whether it's 2-engine taxi. And it could also tell all those other things like APU usage, what the takeoff weight was, takeoff fuel was, what the landing fuel was, all that.
All right, thank you, sir. Next question, again from Captain Pershing. For some legacy systems like C-130Hs, are you able to use a system like their AirCat? Over.
AirCat. I'm not sure I'm familiar with AirCat.
Captain Pershing, are you on? Can you clarify? Over.
Yes, sir. Sorry. AirCat is a system that C-130H is used to go ahead and log all sorts of information, including different sections or segments of their flight, to include cruise, low level, things like that, to include your fuel tracking data. So since they don't have a flight data recorder to actually pump that data in for you, the crews are very diligent about logging this stuff in that system.
Boy, that'd be a great another data source, wouldn't it? And AirCat has nothing to do with like ForeFlight. It's not a ForeFlight product. It's its own separate C-130 product.
Correct, sir. It's an Air Force system. I can get you some more details on it.
Yeah, that'd be great. Because we we burn a lot of fuel in C-130s, and it'd be good to know whether we're pulling that data or not. Because that's the first time I've heard of that. I've heard of other systems, but the first time I've heard of AirCat.
Yeah, and Captain Pershing, can you copy my shop on it, the Chief Data and AI office, at my email address? We're actually responsible for collecting structured metadata around different data sources. So this is one we'd like to be able to include. Over.
Yes, sir.
All right. Next question from Mr. Zach Chester. Are you recording or tracking weather data along with the aircraft data? Over.
I would say that we haven't been doing as much of the weather data, and my data scientist would be able to tell me whether that has been part of some of the other things that we're doing. I can tell you this, is that we're just getting ready to start off with working with the 14th Weather Squadron to start doing more predictive analysis of weather, because I saw somebody else had talked about this issue with understanding what the weather effects are going to be in the future. And so my boss, the Honorable Dr. Ravi Chaudhry, he wants us to work, because we've been given a mandate from Congress to develop a joint way of collecting weather data and then providing predictive analysis for the future. Because we need to understand 5 years from now, 10 years from now, when we do these war games, they're usually 10 years out, and things will change between now and then, and having better informed understanding of what the temperature is going to be like, what the number of storms they're going to have. That'll dictate how maybe a scenario might change, because now we'll know what the differences are. Because, as a former pilot, I know very well that, high, hot, humid, not good for aircraft, not as much lift. And you have to understand those things to understand how much fuel you can carry, how much cargo you can carry, how far you can go.
All right, next question, Ms. Shirley Lennis, is how is climate impact on fuel consumption being considered?
So we're a pretty small piece of the overall picture. So there's a lot of discussion about, like, let's say, sustainable aviation fuel and how the Air Force could really be a mover in sustainable aviation fuel. We burn less than 1/40th of the overall U.S. aviation fuel, and we're the biggest in the government, right? So we, with our initiatives, track the greenhouse gas reduction, because there is something to be said about, if someone's interested in that, an investment in aviation platforms that'll make them more efficient can, in some cases, be extremely more impactful than an electric car, right? Or, other things that we're doing right now to try to mitigate greenhouse gas emissions. And so from that perspective, we know, like, I could just off the top of my head, a gallon of JP8 or Jet A is about 6.8 pounds, and 6.8 pounds of JP8 produces about 20 pounds of greenhouse gases, about 20 pounds of CO2. You wouldn't think that, but if you realize that you're pulling in a lot of air, which is a very much heavier molecule, and you're connecting it with hydrogen, with carbon, and as part of that hydrocarbon, so that CO2 becomes much heavier. So we understand that, and when we track our initiatives and we say it saves this much fuel, we usually will use that 6 pounds to 21 pound conversion to be able to understand what the GHG emissions are of that particular operation. That's about as far as we get into that, though.
All right. Final question here, number 7, question 7 from Mr. John Roth. How much does your organization interact with outside industry?
Yeah, so quite a bit. As a matter of fact, so the discussion on engine coatings and engine washing and windshield wipers, we're all doing a lot of that with Delta. So we have a lot of Delta data on some of the engine washes that they've done. Also, other airlines, but Delta seems to have a really proactive sustainability department. And, for them, it's not everything that the commercial airlines do are going to work perfectly for us, and understand that. But there are some things that are just no-brainers for us that we need to be looking at. Coatings. So you'll start seeing our C-17 aircraft. That's the biggest burner of all of our aircraft. We're going to start using this advanced coating that'll be part of the supply system, so that when we rebuild the engines on those aircraft, that they get new compressor blades that are provided with these coatings. Well, what does a compressor blade coating do? Well, the shape of the compressor blade is key to the amount of compression performance it has, which is key to the amount of efficiency it has. A misshapen compressor blade, and we've had hundreds of compressor blades in our engines. Misshapen compressor blades drive up fuel, drive up engine temperature, and that engine temperature, the hotter the engine runs, the worse engine life it has. So Delta Tech Ops has worked a lot with us on this whole idea of scanning blades, coating blades, and then washing the engines correctly, as well as the windshield wipers. And then I've visited over the past few years Delta, American, UPS, FedEx, United, and so we see things that they do. For example, their dispatch services are different the way our dispatch services are at the TACC at Scott Air Force Base, but there are valuable lessons that we can learn from them. Like, their dispatchers have to travel with their air crew every once in a while. That communication results in better dispatching services, because the folks doing the plan understand what the challenges are of the pilots, and vice versa. We're doing the same thing, where we're actually giving money to the folks at the TACC, so their flight planners will fly with air crew and see the challenges that the air crew and the load masters and logisticians have with the aircraft operations, that will in turn result in, combined solutions to make us even that much better.
All right, sir. So there is one question that came up, and this one does touch me personally, because I experienced this. I have, unfortunately, I've got 6 cars on my at my house. There's 5 drivers, and it doesn't matter if it's a 4-cylinder or the 12-cylinder. There's 2 members of my family that always get 13 miles to the gallon, depending on which car they're driving. And so this question says, is there any significant variance you see on a pilot by pilot basis? Do y'all track that?
So we're not trying to make it punitive, much like the airlines. I think the airlines will actually maybe track a pilot's behavior and have a discussion with them, but a sanitized discussion with them to understand what they were doing as compared to what should be done. For us, it used to be, at least, my old boss, Fred Ruggiero, was the A3 of AMC. There was a time where I think the squadrons were actually tracking all the individual pilots, and we can look at it from a flight perspective. There are a lot of variables. I would tell you that what we're trying to do right now is compare, like this MEEP program is really a comparison of different units, and you do see a pretty drastic difference between units that want to play and units that are just, that are not really trying. And that can result in, what we saw. So, you had 4 squadrons basically generate about 1 million gallons of fuel savings for really no impact on training. And that's in a 1-year period. And we have a lot more than 4 squadrons in the Air Force. So yes, we see a difference. And in that case, of the 4 squadrons, we found one at Travis that really just knocked the tails off of everybody else. And we do a lot of work to in the analysis to make sure that all those factors that could be considered as being different between one place or another are filtered out, so that it really comes down to pilot technique. Because we're not going to tell them you can only take off at this fuel load. That's a recommendation, but you can really tell a difference between someone who says, nope, I want that extra block 10 plus 10, and the person who says, I really don't need that for this flight. I planned it out and I don't need it, and I know the weather, and so I know, what I'm doing, and I can live with this level of risk.
Sounds good. I think I need a DO at my house to control those 2 family members.
Yeah, I did have, like there are apps nowadays where you could stick in with that little ODB2 port where you could stick a little thing in there. So a little obsessed by this energy consumption thing, as you might be able to tell. I'm pretty passionate about it. I have one in my car. I had one at home. That in my it's called. I can't remember the name of it. It's a box that sits in my electrical panel. I actually had to pop my electrical panel off and, wear rubber gloves and keep from electrocuting myself. But that one does a really good job of telling you, hey, your dryer, your clothes are done, your fridge compressor is working way too hard and it might be getting ready to crap out, or your air conditioning, compressor isn't working well. So it does a really good job of kind of telling you how you're doing. And we could see this these days a lot in the products that we get from the energy companies and whatnot. And I've seen the same thing in a vehicle where it would actually beep at me if I was slamming on the gas pedal. So maybe that's a effective alternative, right, to have it report back to you that way.
Yes. All right, sir. Oh my gosh, one more question made it in. This will be the final one. It says, any work done on formation flights for cargo to reduce drag on individual aircraft?
Yes. Over. So that's interesting you say that. I just recently had a talk with Dr. Greg Addington from AFRL, and we're going to try to, now that there's money and manpower against these things that we've looked at in the past, we agreed that we want to take a better look at that in the future. So what he might be referring to is we did have this thing that a friend of mine named who was the chief scientist at Air Mobility Command several years ago had refined this thing they called SAVE, surfing aircraft vortices for efficiency. And what we discovered is that you can get roughly about a 10% efficiency gain if one aircraft flies in the updraft of the other aircraft that are caused by the vortices coming off the wingtips. And so, and the C-17 was the test case that they used on that. And so we're pretty confident that that we're going to at least go back into that business and look at that, because as you start figuring out how we execute TIPFID in the Pacific, you can see how that could make a big difference on aircraft being able to make it back home without having to refuel much. And it also, from a just your aircraft aren't working as hard because they're flying kind of like birds, right? Where they're flying on the updraft of the aircraft in front of them. So that's our next step. It's going to require a software modification to the aircraft, and that'll take a little bit of time and money. But we think that there's some there in the long run from both a financial savings perspective, but a capability perspective that we hadn't realized earlier on, or we hadn't done the modeling in sim to fully validate that.
All right, sir. Well, thank you very much for joining us today. That concludes our presentation. We'd like to thank all of the people that attended today's program, and with the support of our DoD innovators, Innovation Connect has become a success, and we look forward to spotlighting more innovative projects in the future. Approved videos for our Innovation Connect events are available on the Department of the Air Force CDAO YouTube page. And if you have a future topic for Innovation Connect, please send your recommendations to the DAF CDAO Communications mailbox, and our team will review your proposal. Also, please follow our LinkedIn, Instagram, and Twitter accounts for future events and registration information. Sir, thank you again, once again, on behalf of Mr. Dream. Thank you for joining Colonel Kehoe, and this is a wonderful presentation. So it's great to see this innovative work being done across the department.
Really appreciate the opportunity to speak to you all, and want to hear more about other things that you all are working on. So thanks again.
Okay, thanks, sir.
All right, out here.
Out here too.